Okay, we want to talk about another type of angle in a circle. It's called an inscribed angle. We already know about central angles. I've got a picture here, and in this picture, circle P, angle 1, or angle APC, is a central angle because its vertex is at the center of the circle. We know that the measure of a central angle is the same as the measure of the arc it intercepts. So angle 1 intercepts arc AC, and I'm saying it's x degrees. So angle 1 is also going to be x degrees. We want to look at another type of angle here. We want to look at angle 2. We call angle 2, or angle ABC, an inscribed angle. An inscribed angle is an angle whose vertex is on the circle, and the vertex of angle ABC is B. Now, notice that angle ABC, or angle 2 here, our inscribed angle with its vertex on the circle, also intercepts the x degree arc. So we'd like to see its relationship to x. Is it the same as x, or some fraction of x, or what's the deal? Well, if we notice here, PB and PC are congruent because they're radius, both radii of the same circle. That makes triangle BPC an isosceles triangle. And we have a theorem that says base angles of an isosceles triangle are congruent. Way back from first semester, we have another theorem that says in a triangle, the angle that we create by extending one side, for instance, if we're talking here about PBC as being our triangle, if we extend one side of it, we create this angle 1. That's called an exterior angle. We have a theorem that says the measure of an exterior angle is the sum of the two farthest away or remote interior angles. Well, that means that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. Well, the measure of angle 1 is x. And so I can put an x over there, and we know angle 2 and angle 3 are the same. So I can replace angle 3 with angle 2. That's a substitution if you think back to what we did first semester. That means 2 times the measure of angle 2 is x, or the measure of angle 2 is x divided by 2. And in this one special case, at least, where we have one of the sides being a diameter, we've established a rule. The measure of an inscribed angle is half of the arc it intercepts. It turns out even in all of the cases where we might draw inscribed angles, that will always be the rule. So, our new rule, without all the extra stuff on it, is this. In a circle, an inscribed angle looks like this guy, and however big the arc it intercepts is, the angle is half of it. So the measure of an inscribed angle is 1/2 the measure of the intercepted arc. I'm just going to write measure of arc because I'm running out of space there. Okay, other rules in this section are not as important as that one. This rule gives us all of the others, but you'll work a few problems where they'll come in handy. Okay, look at this situation. In this circle, let's highlight some arc. Let's put an arc up here in blue, and let's whatever call it arc AB. Okay. Notice here's an inscribed angle. Angle 1 is an inscribed angle that intercepts arc AB. Now, if arc AB, let's put a number up here. Suppose it was 60, we would know that angle 1 is 30. Now, suppose I've got some other angle in the picture. angle 2, which I have a marker that's not dry. We can draw an angle 2. All right. Here's angle 2. It's also intercepting that 60. It's 30. Well, look what we've done. If two inscribed angles are intercepting the same arc, in this case a 60, then they're both half of 60. But no matter what number's sitting up here, both of our angles will always be half of it. So our rule, I'll lose the 30s and the 60s and just show this. When two inscribed angles intercept the same arc, those two inscribed angles are congruent. Now the truth is they really don't have to intercept the same arc. They just have to intercept arcs that are equal. So even if they intercepted two different 60s, they'd both be half of 60 would be 30. So the words go something like this. If two inscribed angles intercept the same arc, or congruent arcs, then the two angles are congruent. So that's the picture we've got here. Two inscribed angles intercepting the same arc, and you see the congruent marks on the two angles. We've got another one here. I'll say one more because there's two. But one more that I can easily fit in. Suppose that this is a diameter of some circle. Then it divides the circle into two semicircles. And if I would inscribe an angle in that semicircle, in other words, if I would get an angle in here, an inscribed angle that intercepts that upper semicircle, then I know its measure, the measure of the semicircle is 180, so the angle has to be half of 180 according to that rule. It's got to be 90. So the rule just says in words that an angle, an inscribed angle, that intercepts a semicircle is a right angle. Okay, we have one. You might want to get those down because I'm going to have to erase. We have one last rule in this chapter, in this section, and it is involving a quadrilateral that's inside of a circle, inscribed in a circle. Picture looks like this. There's our circle, and inside of our circle we're going to have a quadrilateral that has the property that all four of its vertices lie on the circle. Okay, if all four of the vertices lie on the circle, we say that the circle ABCD, the quadrilateral rather, ABCD is inscribed in the circle. All right, let's take a look at a pair of opposite angles here. Let's look at angles A and C, for instance. Now, let's suppose that arc right there, arc BD, has measure x degrees. Then since angle A intercepts it, and it's an inscribed angle, the measure of angle A is x divided by 2. Okay, now if this arc is x, then the rest of the circle, this guy, which is arc DAB, would have to be 360 minus x. Well, the angle at C, angle BCD, is inscribed and intercepts it. That means its measure is 360 minus x over 2. We want to see what they add up to. So if we look at this pair of opposite angles, the measure of angle A plus the measure of angle C, we're going to get x over 2 plus 360 minus x over 2. That's x over 2 plus 360 over 2 is 180. Then I get a minus x over 2. Well, the x over 2 minus x over 2 is 0. We get 180. So what we have here is that when a quadrilateral is inscribed in a semicircle, its opposite angles are supplementary. They add up to 180. So here I can say that A and C add up to 180, and there was nothing special about the way I did this with respect to A and C, so I can also say, because I could have done the proof for angles B and D, the measure of angle B plus the measure of angle D is also 180. In words, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So with that information, we should be able to handle all of the homework that's in section, I guess we're in section 10.4 now, on inscribed angles. In the next video, I'll do a few example problems.